Okay, so hopefully you had a chance to watch the video and you noticed a couple things in there that really were references to reliability and validity. So let's start off with the comments he makes in the video. He says that the price or the quality of the scale really does not matter. And so it's important to know that when you're thinking about validity, when you're thinking about what do you care about, that's when you're thinking about validity. Because validity isn't necessarily what is true, but it's what are you trying to get at. In his case, he doesn't really care what his weight is exactly. He just cares whether he gained weight or he lost weight every single day. So for him, validity is all about changes. In psychology, we always have to choose what we care about. We have to operationalize our stuff, right? So if you're trying to assess happiness, there's no necessarily accurate, perfect way to measure happiness. And so we wouldn't necessarily care about what number we get, just like he doesn't necessarily care about what number he gets. What he cares about is how consistently he gets the number. And so in this case, he is looking for reliability, and as long as it's reliable, it's valid to him. He mentioned avoiding ones that are made of glass because glass can break, and not only is that dangerous, but that could give you a bad reading. It could give you inconsistent readings, and that's not really what we want. That's not very reliable. He says the body fat ones aren't realistic. That doesn't actually measure body fat. If you're in, so he's saying that the body fat measurement systems on scales are not valid. And he says if you want to measure your body fat, you should get calipers. And so he's saying, okay, well, calipers are a valid way to measure body fat. That's not what we're here for. And so you shouldn't be worried about that in terms of the validity of these scales. Then he says also that the pointer scales are not very accurate. Uh, and then he gets to actually weighing himself. And so he gathers some data on 3 different scales to see whether the scales are reliable. And it's important to note that reliability is going to be our gateway to validity. We can always make an argument that something is valid because we get the same result, or because we try it a bunch of different ways and get similar results, but it's basically impossible to be 100% sure about your validity. On the other side, it's really easy to be 100% sure about your reliability. It's really easy to be sure that the scale is giving you the same result. So we might not know exactly what his weight is, but he knows that all the scales that he's using give him roughly the same results, and that they all say around 205. And so he kind of concludes in there that he weighs probably around 205, and now that he knows that, he can use that to check other scales weighing. And also another way to check the validity of your scales is he says, well, it doesn't matter what numbers they give you, because as long as it's consistent, you can validate that with another scale and then calibrate yourself to know how much it actually is you should put on or reduce based on the measurement. All right, so let's take a look at the numbers that he puts out. So what I've got here are scale A, he says 204.6, and he gets the result the same the second time and the same the third time. For scale B, he gets 206.2, so I'm just going to say 6.2. And he gets the same result the second time and the same result the third time. For scale C, though, we're having some trouble because for scale C, he gets 205.2. But then on the second try, he gets 205.4. And then on the third try, he gets 4.8. And so we know that scale A and scale B are reliable. They give us the same result every time. And so even if the result isn't exactly the same, we know that we can trust those scales to tell us the same thing every time. And so we can be sure that if I weigh myself tomorrow, the difference, the change in that weight is going to be having to do with any change in my weight instead of the scale having problems. Scale C is not reliable. It's changing. It's got a range of from 0.8 to next 0.4, so it's got a range of 0.6. You know, a little bit more than half of a pound range there, just in those three measurements, which is telling me it's not a very reliable scale, and if it's not reliable, there's no way it could be valid. Like I said, you can be valid without you can be reliable without being valid. These scales are giving him two different numbers, but they consistently give him the same between each scale. But there's never going to be a way to be valid if you're not reliable. Just to go through what the things that he said, remember that reliability is the consistency of the measure and that validity is the accuracy of a measure, how well you're measuring what you're trying to measure. Measurement error, here this new term, is any situation where you measure something and for some reason either you make a mistake or your tool is inaccurate and so it gives you an inaccurate result. Measurement error could be, for example, that when you use those pointer scales, they're not very accurate, and so they give you a slightly different reading every time. Or it could be that when you get on the glass scale and it breaks and it gives you a slightly different reading. Or a measurement error, the scale itself is not very reliable. Another way to get measurement error might be that you don't read the scale correctly. Maybe you have bad vision and that you have trouble reading what the scale says all the way down at your feet, so you don't consistently get a good measurement. So all of those situations are going to be measurement error. Okay, and so when we come back, we'll check out some subtypes of reliability and validity. Hopefully the topics here made sense. If they don't, you may watch through the video again, maybe try some of the activity, or maybe learning about the different subtypes of reliability will help you understand.